Hello students, in this video we are going to understand the various representation of discrete time signals. In the previous video we have already discussed about various types of signals in which the main classification was continuous time signal and discrete time signal. And as you know, discrete time signal can be obtained by a continuous time signal with the help of sampling frequency. That means a continuous time signal can be represented by its corresponding samples. So that discrete time signal has various representations. So when you solve the numericals, you may have various types of representations by which you have to solve the question. So after the various representation, in this video we are going to solve a numerical also, in which various operations like multiplication, addition will be taken. So first we will see the various representation. The first representation is sequence representation. So the sequence representation is x of n is equals to 1, 2, 3, 1, minus 1. So all the numbers are separated by commas and they are under a curly bracket. This sort of representation is called a sequence representation. And as you can see an arrow below a number, this arrow indicates the zeroth sample. That means this value 3 represent at n is equal to 0. So such type of representation is known as sequence representation. Next representation is known as a graphical representation. As the name suggests, you have to plot a graph of any sequence or any signal. So as you can see, this 3 belongs to n is equals to 0. So at n is equal to 0, the sample is having amplitude 3, and then previous to that minus 1 and minus 2. So at minus 1, sample is having amplitude 2, at minus 2, sample is having value 1, and at n is equal to 1, it is 1, and at n is equal to 2, it is minus 1. So this type of representation is known as graphical representation, in which at x-axis you are having n, and at y-axis you are having xn. The third type of representation is a functional representation. Functional representation can be represented in such a manner that x of n is equal to some value for, that means x of n is equal to 1. So for how many values or how many numbers it is giving value 1. So at n is equal to 2 and at n is equal to 1. It is giving the value as 1. Then 2 for n is equal to minus 1, 3 for n is equal to 0, and minus 1 for n is equal to 1. Sorry, 2. Minus 1 for n is equal to 2. So this is called the functional representation. In this question, the functional representation may not give you a proper idea, but for example, if I write ut is equal to 1 for t is greater than equal to 0 and 0 for t is less than 0. So this representation is a functional representation. So this type of representation is used when a single value represent for many number of n. In such cases, functional representation plays an important role. Last is the tabular representation. In tabular representation, it is in the form of a table. In the first row you write n, and in the second row you write x of n, that is the function. So for different values of n, what is the function value? So for minus 2 it is 1, for minus 1 it is 2, for 0 it is 3, for 1 it is 1, and for 2 it is minus 1. So accordingly I have arranged all the values in a tabular format. That is what is known as tabular representation. So these are the various representation of any signal. One more thing, this we have already discussed the shifting property, but in other words I am telling you this. This is known as time delay. That means xn delayed by k samples. So if a sequence xn is delayed by any sample k, it is represented by x of n minus k. Here the important thing is k is having a positive value. And another thing is known as time advance. It is denoted by x of n plus k, and you can say xn is advanced by any number k, where k is negative, because x of n plus k is basically x of n minus of minus, which comes out to be x of n plus k. So this is advanced. So whenever you see x of n plus something, that means you have to advance your signal, and if you are having something x of n minus 1, 2, 3 or something like that, you have to delay the sample by that much number of samples. Okay, so this is all about various representation of signals. Now we will take a question, a numerical, and we will solve by performing various operation on that particular question. So let us take this numerical and we will solve all these 6 points. After solving all these 6 points, the concept of various operations will be understood to you very easily. So the question would be something like this. A discrete time signal is represented as x of n is equal to 3, 1, 2, minus 1, 2, and the arrow is at 2. So that means this is the 0th sample. This is n is equal to minus 1, this is at n is equal to minus 2, this is at n is equal to 1, and this is at n is equal to 2. This is how sequence representation of a signal is given. Now what you have to do? First is plot xn. That means what you have to do? You have to represent this sequence representation in a graphical representation. Then delay xn by 2 sample. That means what you have to do? You are supposed to use the shifting property or shifting operation. Then advance xn by 1 sample. Again this is a shifting operation. Then fold xn, folding operation. TD FD of xn is not equal to FD TD of xn. This you have to prove. This is basically a, you can say, theorem. Xn is the sequence. First you have to fold it and then you have to delay it by any number of sample. Similarly, this is the same sample. First you have to delay the sample by some value and then fold it. And then you have to check whether both the operations are same or not. And finally plot x of n minus 2 into del of n minus 2, where del is the unit impulse function. So that means first you have to delay your sample xn and then you have to multiply it. So that means we are using multiplication operation. So one by one we will see. First we will plot it. So it is very simple. At n is equal to 0, it is having value 2, 1, 3, minus 1 and 2. 0, 1, 2, minus 1, minus 2. This is n and this is xn, and this is the value 2. So very simple. You just have plotted the xn. Now delay xn by 2 sample. Delay xn by 2 sample means you have to shift all the samples by 2 values. So that means it will be 3, 1, 2, minus 1 and 2 again. But now this minus 2 sample will shift it towards the right hand side. That means minus 2 will be at 0, so it will be 0, 1, 2, 3 and 4. So the sample which was existing before at n is equal to minus 2, now it will exist at n is equal to 0 and so on. Same way all the samples you have shifted towards the left side. So this is your second part. Third part is advance xn by 1 sample. So advance xn by 1 sample means you have to advance, that means you have to move your signal from right to left. So again it will be 3, 1, 2, minus 1 and 2. But now this sample minus 2 will be minus 3. So that means all the samples are shifted towards the left side. So the sample which was previously existing at n is equal to minus 2, now it will exist at n is equal to minus 3. So this is your third part, which is x of n is advanced by 1 sample. Now the fourth part, fold xn. Fold xn means the sample which exists at n is equal to 0 is 2. Now this sample will exist at n is equal to 1, which is value having 1, and the sample at 1 will be transferred to n is equal to minus 1. So at n is equal to minus 1, your sample is minus 1. Similarly, the sample at 2 will be at minus 2, and sample at minus 2 will be at plus 2. This is 3, this is 1, this is 2, this is also 2. So this is the folded xn. You just transferred all the negative samples to the positive side and all the positive samples to the negative side. So you have just reversed, except for the sample at n is equal to 0. Now the fifth part, TD, FD, XN, FD, TD. So let us do this part. Already we have delayed the sample, delayed of xn by 2 samples, which is this. So this part we have done, time delay. Now we fold it. So we fold it, how, what you will get? You will get sample at 0 is 2. This is 3, so 0 will be 3, and then 1 will be minus 1, which is this. 2 will be 2, 3 will be minus 1, and 4 is also 2. So this is 0, minus 1, minus 2, minus 3 and minus 4. All the samples existing at 1, 2, 3, 4, now you are folding it, so they will move to the negative side. That means sample at 1 will be now at minus 1. Sample at 2 will be now at minus 2. 3, minus 3. 4, minus 4. So this is FD, TD of XN, where we have delayed the sample by 2 samples. Now this part, folding. So we have already folded this. This is the folded part. Now you will delay this sample by 2 value. So now you are delaying this, which is minus 2 will be at 0. So this will be 2, minus 1, 2, 1 and 3. But 0, 1, 2, 3 and 4. So this is TD, FD of XN. That means first we have folded, this is the folding, and then you have delayed by 2 samples. So minus 2 will be at 0, so you have done the operation FD-TD-XN and TD-FD-XN. As you can see, both are not same, both are different. So this is proved, which is TD-FD-XN is not equal to FD-TD-XN. That means first fold and then delay, first delay and then fold of the same XN. Both are not same, which we have proved. Finally, plot x of n minus 1 into del of n minus 2. So this is your xn, this is your xn. First you will calculate x of n minus 1. X of n minus 1 means what? 3, 1, 2, minus 1 and 2. But it will be minus 1, 0, 1, 2 and 3. Why? Because I have shifted or I have delayed this xn by 1 sample. So minus 2 sample will be now at minus 1. So this is your x of n minus 1. Now you have to multiply it with what? Del of n minus 2. Del of n minus 2, what is del of n? Del of n is equal to 1 for n is equal to 0 and 0 otherwise. This is your del of n, which exists only at 0. But now you have delayed it, so value 1 will be exist at n is equal to 2. So it will give value 1 at n is equal to 2. When you multiply it, all the other values will be 0 because it is giving value 1 at only n is equal to 2. So the resultant answer will be at n is equal to 2, it is giving minus 1. So minus 1 into 1 is minus 1. So this is your x of n minus 1 del of n minus 2. That means first you have to delay your signal, then you have to delay your impulse signal, and then multiply the corresponding samples. As you can see, only at n is equal to 2 you will get something, all the other values will be automatically 0 because there is no value existing in this del of n minus 2 other than n is equal to 2. So at n is equal to 2, your x of n minus 1 is giving value minus 1. So minus 1 into 1 will be minus 1. So this is the answer. So this is how you can perform various operations, and this is how you plot different signals. I hope you understand the concept. If not, you can write it in the comment section. We can discuss it further in other videos.